Welcome to the lecture on surface and subsurface welding defects. So, we had the introduction to some of the welding defects and also we discussed about the causes of those welding defects. And in this lecture we are going to have some detailed study of typical welding defects which usually occur in the different welding processes. Welding processes may be arc welding processes or other than arc welding processes, and we will only have some discussion by referring to the typical images of certain type of important welding defects, and also as we discussed that also about the different type of welding processes and related defects. So, as we discussed that normally you have the surface defects and you have the subsurface defects in the case of welding, and then these defects may be because of the arc welding, because most of the welding processes are based on the arc welding principle. So, we will have some understanding about the defects based on arc welding processes, and then also we will discuss about some prominent type of welding defects which occur because of the other welding processes, like maybe resistance welding defects or friction welding defects. So, if you come to the arc welding defect, then as we know that this is these are on this side you have these are the surface defects, and this is among the subsurface defects. So, they are visible on the surface or they are visible outside from outside, whereas these defects are inside the geometry, and they need to be seen using microscope or so. So, coming to the cracks, so we have studied very much about the cracks, and as we see that you have the if you talk about the cracks. So, we have already studied that there are many reasons, and this is because of the high contraction stresses. So, when these stresses result into and its value is more than the strength of the metal at that particular high temperature, in that case the crack results into, then it may be because of the poor fit up and also incorrect welding procedures, and then you may have also the poor edge qualities. So, this way you have the emanation of the surface cracks. We have already seen that there are longitudinal cracks, there are transverse cracks, there are crater cracks. So, these different type of cracks are available. Then if you talk about the different processes, so in many cases if you have the deep penetrating processes, so like you have the you have a CO2 welding, then you have SAW. So, these combined with narrow weld gaps, if they are combining with narrow weld gaps, so they cause the hot cracks, and normally at the root. So, they will be causing the hot crack at the root level. Similarly, if you are having the very high welding speed, in those cases also you have the chance of cracking. So, high welding speed causes cracking, especially in aluminum weldments. So these are the different reasons for the crack. Then you talk about the different types of cracks. We have already studied that there are depending upon the way they are oriented, you have longitudinal and transverse cracks, you have the crater cracks. So these are this is seen as the longitudinal crack. You have the presence of the transverse cracks, and then also you can see here these are the crater cracks. So crater cracks normally occur when the welding is interrupted. So as you see this crack which you see, because this is interrupted, so there basically there is a tendency of the crater to of the crack to form in this crater. So normally they are of star shaped. So that also we had seen in our earlier lectures, and as we see that these crater cracks are normally because of the material properties also, because when the material has very high coefficient of thermal expansion. So in those cases like austenitic stainless steel, so in those cases these crater cracks are very much likely to happen as it seems to be. So there are certainly some reasons also for that. Then the next type of the defect which is very much prominent, so that is your incorrect weld profile. So if you look at the weld profile, so normally what you see is that this is the desirable weld profile in the case of fillet welds, and this is how you take it as the acceptable ones. So this may be acceptable in those cases. So if you see that this C is basically showing the convexity which is shown here and here also. So this may be acceptable, and what you desire is like this. So this is what is desired normally in the case of fillet weld. However, you basically see many a times different types of weld profiles in case of fillet welds, and if you see these kind of welds normally you come across, which is basically not desirable, basically not acceptable. So if you look at this, so here you have the insufficient throat. So that case is there in this case. If you look at this, now here you see that this is excessive convexity which is found in this case. Now if you look at this is in this case you have the excessive undercut which is shown here. Then if you look at this geometry, this is the case of overlap, what you see on this side also. This is overlap is seen in this case. If you see this weld profile for the fillet weld, now in this case what you see is that you have the insufficient leg that is there. So this is this type of fillet weld profile is not acceptable in many cases. Then if you look at this case, now here you see that there is no proper fusion which is observed in this case. So you have the case of incomplete fusion in such cases. So these are basically the incorrect weld profile in the fillet weld. Similarly, you have the also weld profile which is acceptable. It may be there in the case of butt weld, and in butt weld also you may have the different kind of profile which is not basically acceptable. So if you look at a proper butt weld, so it will be shown like this. So, on both these sides you have, so this is how you will have the convexity. So, so this way the actual the allow what is acceptable butt weld profile should look like. Again you will have the the R which is here, that is defined. This R is basically denoting the reinforcement. So, and then in butt weld there may be a different kind of problems, like you may have the excessive convexity. So, you will have so you may have such kind of excessive convexity will be there. Then you may have the insufficient throat may be there. So, it may go like this. So, this way if it goes, this may be a case of insufficient throat. Many a times what we see is that so from here basically your weld profile looks like it will start from here. So, basically it will be a case of excessive undercut. So, that way the weld profile may look like. So, similarly there may be overlap. Many a times you have this way. So, it will be going like this. So, you will have the overlap. So, this way your overlap kind of defect also may occur. So, this way different types of incorrect weld profiles are basically caused while welding. Now, so you will have to follow this specification, and accordingly you will have the production of the acceptable weld profile in the cases of welding. So, there may be many reasons for sometimes the undercut or maybe the overlap. So, you will have to have the control of the parameters to avoid these defects. Then if you look at the other kind of weld profile which is not very much acceptable. So, apart from that you may have the dimensional defects. So, then that is maybe because of because the shape or size which you want to achieve that is not properly achieved. So, that may be the dimensional defects. Then you may have defects like you may have the overlap. So, as we saw that you may have the overlap, and overlap basically will be producing the mechanical notch. So, overlaps are many times formed, and this overlap will be forming the mechanical notch, and that will decrease the property of the weld. So, basically a crack may start at those points. So, that notching, due to notching effect, you may have the formation of the cracks, and that will ultimately reduce the strength. Then there may be undercuts also, as we saw. So, these undercuts, they are normally located parallel to the junction of the weld metal and base metal at the toe or root of the weld. So, that way you get these location of these undercuts, and they also lead to cracking, because they normally, so once there is undercut, so they reduce the cross sectional area, and because of the notch effect, again there may be failure in the material. Undercuts may be because of the excessive arc voltage and even current values also. So, many a times the undercut is formed because of those reasons. Apart from that, you have the among the surface defects, you have the presence of surface porosities also. So, surface porosities basically occur when the welder is basically using the undried covered electrodes. So, many a times he is using these undried and covered electrodes. So, or electrodes with the shelf life that is whose long shelf life has expired. So, it has long expired. So, in those cases you will have the presence of the surface porosities, because they contain the moisture, and then that basically leads to the presence of these surface porosities, and so that basically has to be avoided. Apart from that, you also have the many a times you come across the surface oxidation. So, when you are doing the welding of metals which are very easily oxidizable, like if you take the example of aluminum or titanium or magnesium and their alloys. So, the surface oxidation will take place in these cases, and typically it will happen if you are not providing adequate shielding environment near the surface. So, in those cases the surface oxidation takes place, and that will be certainly, if oxides are formed, then that will be detrimental for the product quality or the weld quality. So, this is another type of defect which occur in the case of welding. If you say other defects like on surface, what is taking is uneven and coarse ripples. So, basically what is happening, that these ripples, if they are found on the surface, they will be aesthetically not desirable. So, the appearance on the surface, that will be so there will be inconsistency in the appearance. So, normally you will have the generation of these because of the uneven heat inputs many a times. So, many a times these because they are aesthetically so important. So, many a times because of that the rejection will be more because of these factors rather than the internal flaws which are there in the material. So, this is these are the kind of surface defects. Apart from that, you also get some marks, that is your flat spots or pock marks also you get in the case of flux core arc welding or submerged arc welding. So, they will be like you have the form in the form of slight depressions which will be there. So, because of the improper welding current or so. So, if you control these welding currents and gas flow rate, then and also the moisture content of the flux. So, you can have the control on these pock marks. Many a times we also see that you have the excessive spatter. So, as we have you might have the idea that this kind of defect is caused by the arc blow, which is because of the wrong selection of electrodes, or maybe you have the bare electrode or with the use of heavy current. So, there is excessive spatter occurs. It may be because of the poor technique of the welder also. So, you can have the prevention of this spatter by suitable coating to the metal adjacent to the weld. So, that way you can have these the avoidance of these excessive spatter. Apart from that, you have other also surface defects like there are arc strikes or so. So, when the welder will hold that or inadvertently or without knowingly, it strikes the electrode or the when it strikes the electrode against the work. So, in that case you have the arc strike is taking place and you have the unwanted arc. So, that can spoil your finished work also. So, these kind of the surface defects may occur. There are examples of even the if you come to the subsurface kind of defects. So, these so far we discussed about the defects which are visible. If you talk about the subsurface defects, in the subsurface defects again you will have the cracks which are internal cracks. So, internal cracks will be seen in the case of subsurface cracks. So, and apart from that you will have the so if you come to the subsurface cracks, so you will have the so that is known as internal cracks. So, in that basically you have the underbead cracks, as we had already seen that these underbead cracks are basically the example of these cracks which are not seen from outside. They are cracks under that region, and you have also many times you have small cracks like fissures are also there. So, and also you have extremely small, so then we call it as micro-fissures. So, they are very much dangerous. They are considered to be very much dangerous because they will be creating a large reduction in the strength. So, these cracks are more important because they will create sudden failure of the material, especially under the impact loading or the kind of low temperature surface conditions. Then among them the under subsurface defects, you have the lack of fusion. So, as you see that there will be in many cases you will have the weld profile which is here. So, basically it goes like this. So, you will have the lack of fusion taking place in this region. So, that is also the called as the incomplete fusion. So, mostly in case of multi-pass welding you come across these cases, and in these cases the main reason is because of the insufficient welding current, suppose. Then many times you have the offset of the electrode from the axis. So, or you have the high welding speed. So, these are the main reasons for the lack of fusion, where the one of the side or the edges, they are not melted thoroughly. So, that is how the incomplete fusion takes place in these cases. So, this as just like the undercut of this also will be reducing the strength, and that will be creating the failure of the component. Then apart from that we also have among the subsurface defects, you have more importantly the blowholes or subsurface porosities. So, they basically are formed because of many reasons, and they are because of the presence of rust, dirt or grease. They are normally there. So, if you are not able to clean them, so on the edges of the parent metal. Or on electrode. So, this may be the reason for the blowholes or the subsurface porosity. So, you will have the porosities formed inside. Then you will have the reason one more will be the, if you have the in case of SAW, if you have the damp SAW flux in the submerged arc welding, if you have the damp flux, in that case that may go inside the weld, and you may have the subsurface porosities or blowholes. Then also if you have the impurities and moisture in the shielding gas. So, that may be the reason for the blowholes or surface porosities. Further, you will have the excessive welding speed. So, what happens that the gas pool which is formed around the weld pool. So, when you have the very high welding speed, then that envelope which is created for shielding, that becomes ineffective, and then in that case you have the chances of having these blowholes or subsurface porosities. Then when you are making these the welding over the tack welds. So, welding over tack welds made with lightly coated electrodes. So, in those cases also the chances of porosities are there. Apart from that, you have also the reason is the high welding current. So, these are basically the reasons for the porosities which are formed in the case of welds, and this is normally the known as the subsurface porosities. And porosities basically are of different types. If you look at the porosities, so we can have the example of these porosities. So, what we see, if you look at the in normal case, the porosities will you have the, so this way if you get the porosities, so this will be basically the uniformly distributed porosity. So, this is your uniformly distributed porosity. Then you may have the porosities also of different types. So, you may have the cluster porosity. So, what happens that in that case you will have the porosities in the form of clusters. So, you will have here, then you may have at some places you have the, so in this cluster, so these porosities will be formed in the form of clusters. So, so this is the example of cluster porosity. So, they are basically because of the change in the welding conditions, like changes in the arc settings. So, because of that these cluster type of porosities come up, or sometimes maybe many times you stop the welding. So, in those cases these cluster welding cluster type of porosities develop, and these are basically not very good for the welding. Similarly, you have the starting porosity. So, many a times you will have the starting porosity, and starting porosity will be looking like it will go like this. So, normally it is used when stick electrodes are used, and in that the porosity is spaced at distances just like the weld metal is stuck to the stick electrode. So, that way you normally it is because of the excessive moisture in the electrode covering. So, because of that you will have such kind of the this is basically known as the linear porosity. So, this is this is the example of linear porosity. So, it is normally in the root pass of the weld, but if you talk about the starting porosity, so you will have in the starting regions. So, this is your this region. So, you will have these as the starting porosities. So, you have different types of porosities which is normally come across in the case of the subsurface defects. Apart from that you also come across other defects like inclusions. So, you will have the slag inclusion which is shown as shown in in this case. So, you will have the presence of slag inclusion in the butt weld. So, if you look at this, what you see is that this is a slag which is there in this case, and these are the the brittle slag inclusions which is there in the weld. So, basically it is because of the trapment of the slag, and maybe many a times you have the trapment of the flux that creates, or you have the inclusions which are there inside. So, many a times these slags are forced, in case of shielded metal arc welding they are forced to go inside, and then they are not able to come up. So, they are basically coming up. So, basically they are especially in the multi-pass weldings, when you are not removing the slags, in between you are cleaning the slags. So, these kind of defects come across in these welds, and normally they are detrimental because they will decrease the strength of mechanical strength of the weld. Other than arc welding, if you look at, there are other type of welds. So, if you try to refer to our this slide. So, if you have other than arc welding, you have other welding, like you have the resistance welding and the friction welding. Now, in the case of resistance welding, you have the different kind of welding, and you have the spot welding defects. So, in case of spot welding, you will have spot welding defects are so you have spot welding defects, and in spot welding defects you may have the excessive electrode indentation. So, and then similarly you will have the metal expulsion, then you have shrinkage, void and porosity. So, you have then cracks, surface burning. All these are kind of the defects which are occurring in the case of the spot welding of electrodes, that is under the resistance welding. And you have many a times the electrode skidding also taking place. You have the edge bulging or excessive penetration. So, these kind of defects occur in the case of electrode spot welding, and you get to know many a times if you talk about the the defects. So, this is what you see is that this is the porosity and burning. In the case of aluminum spot welds, what you see, this is the porosity which is seen in the case of spot weld. Similarly, you have the case of burning that is also observed in the case of aluminum spot welds, and that is shown by this picture here. And similarly, in the case of other welding processes, you have the process like you have the you have other defects, like you have the separation of sheets or so. So, this way the different kinds of defects occur in the case of resistance welding also, and there basically you have the material properties that also plays an important role, and basically the process parameters which will be like the property of the material or the value of the current and the what is used. So, those important parameters are to be looked into to avoid such kind of defects, and you need to study more for understanding for the better understanding about the different types of defects which is likely to come in the case of these other kind of welding processes. Thank you very much.